Okay. All right. Good morning, ladies and gentlemen. I hope you have had a great week. Here in South Africa, it's our first week, our first full week of the lockdown. Behind me, you will see Bob. He'll keep me company during today's session. And I just want to thank everybody from Gravity side. I think there was a lot of effort that went into this. The entire team, the picture you'll see in the actual slideshow has been done by our incredible in-house graphic designer, Donnie Nell. We've had input from our training manager, our managing director, even our company director gave us some input. Yeah, I'm quite excited. We are still waiting for one or two guys more to join us. But I think our main focus for today will be the fall protection plan and the implementation side of it. So just to make sure that everybody understands the foundation, I think we have a lot of different types of job specification people that are joining us today. So there will be safety managers, safety officers, there will be normal supervisors, and CEOs, I suppose, as well. So, and across the board, we've got construction guys, we've got telecoms guys, we've got steel manufacturers. So there's a whole lot of different areas. And I think the nice part is there's a nice section on the Q&A. You'll see as one of the options, you can post questions there. Our training manager, Yandre, will be our producer, which is quite cool. So he will then make sure that those questions are then formulated correctly, and we'll post it, and then we'll have a discussion as a group. I think it's a little bit different for me. I'm normally quite used to see faces, and I can see when my topics are getting across. So today we'll really rely on your questions and that you put on those things on the questions and answer box. I'm quite certain it will work, and I'm excited. And yeah, let's wait for 1 or 2 minutes, and then we can actually start. I think there's 1 or 2 guys that still need to join us. In the meantime, just familiarize yourself with all the buttons and stuff on the Teams so that you can find out where those questions and answers buttons are. Thanks. Let's wait 5 minutes and then we can start. Right. Okay. Great. It's 9 o'clock, and I like to be quite on time. So hopefully the guys that are still joining us, they will catch up soon, and I think we can start. What we want to do is I'm going to start with a quick presentation, just to set the ground foundation, because we've got such a big variety of people joining us. I really want to make sure that we have a nice foundation, and then from there we can have a nice workshop, and we can hash things out and discuss things as part of the slideshow. Every now and then I will stop the slideshow, and we can then discuss some of the questions that may have come up. And yeah, so I think let's start with the slideshow. All right, okay, so we're part of Gravity group, and Gravity group consists of at least three different entities. We've got Gravity group, and underneath that we've got Gravity gear, Gravity training, and Gravity access. So the Gravity access guys, they form more part of the installation of the systems. Like you can see in the picture, there are some guys hanging off rails there. This is a very prominent building in Sandton, and you can see those rails are pretty well designed. They're almost invisible from the average guy walking around there, and there's been a lot of effort just to get those rails designed properly. And then you all know the gravity training side, and also then our gravity gear side. Our gravity gear focuses a lot on the type of gear that we use in training. We supply as in gravity gear, and that's quite important for me, so that the guys, when they receive their training, they know the gear that they use. They can go next door and then buy that exact same kit, that exact same equipment, and then they can then implement it from their side. Right, so let's move on. What is work at height? So that's that. I know it's a basic question, but in my mind, if we go back to climbing, you can see the guy standing there. His name is Alex Honnold, and that's on El Capitan in America. It's a mountain that's about 1,000 meters high, and it takes normal people about at least 3 days to climb it, and he did it in, I think, an hour. But I think the principle still stays the same. If you look at the guy there, work at height is just getting somewhere and then do the job. Okay, Alex Honnold is there to look at the view. He's not actually doing the work, but the same fall risks also apply to him. And I think the biggest difference between a rock climber and a worker is the fact that Alex is not wearing a harness, but most climbers are expecting to fall. They do their risk assessments and their training, and everything works around that because they are expecting to fall. For a guy working at height, he also wears a harness, and there's a small possibility that he might fall, and he manages those risks and everything around them. And you'll see next we have Saki there. Those of you guys who know me, I like Saki. So, and then you can see this is a different option. For Saki, he really needs to make sure that all his equipment is right. He needs to be mentally prepared. He needs to know how to put the equipment in place. In other words, so medically his body needs to be fit. He needs to make sure that he's done the training before he starts the route. And that's the mindset of a climber. Before they start climbing any route, they will make sure that they've got the right training and experience before they start placing equipment. Otherwise, things will go really, really pear-shaped. And like I said, but the thing for a climber is he needs to manage all of that risk assessment inside his head. So when we work at height, there are mainly two types of risks. And you can see here, there's, I think Saki's at the bottom there, and his friend is on top. So the main fall risk that we're looking at when we're working at height is persons can fall. The second thing is, if you look on the right-hand side, there's objects that can fall. That's it. There's nothing else. Those are the two main risks that we have to focus on. And yes, there are many different reasons for that. And we need to make sure that in the fall protection plan and in the risk assessment, we identify the reasons that may cause a person or an object to fall. So if we translate this rock climbing picture to real life, that's what it will look like. Again, you will see there's a person there, Saki again, doing Chinese tricks and silly things and standing on stuff he shouldn't be standing on. But at the end of the day, it will cause him to fall. Saki climbs there, so it's also a person falling. And then if he does fall, it will become a rescue situation. But again, it's still a person falling. Even if there's a major structure collapse, like Saki and his friends hanging there, you will see same thing again. Persons falling, and our second hazards is objects and tools, and you can even see there's a brick coming down. So we need to manage those risks. Legally, there's quite a lot of legal requirements. Typically, when we see a safety file, basically all we see is the outside of the backpack, and we don't really know what's inside. So it's quite important for us to understand what are the legal requirements and not just the legal implications, but what is the inner principle that these legal requirements are referencing to. And I think we can all agree principles always stay the same, rules change. So let's have a look at what those different principles are. The first principle is that the employer creates a safe work environment. In other words, he needs to make sure wherever Saki goes, the environment around him is safe and without risk. Now, regardless of what country you're in, the OSH Acts all say the same thing, that it's the employer or the contractor's duty to create the safe work environment. The second requirement is that the employee maintains that safe work requirement. There's a specific section in the South African OSH Act that says that the employee is responsible to make sure that the requirements imposed on the employer, it's his duty to make sure that those requirements are met. And I think that's quite a nice way of saying it, instead of just saying, the employee must do what he's told. The third principle is we have to follow procedure or standard operating procedures, just to make sure that the first two principles are then properly implemented. And then lastly, and I think that's something that we really need to stress, is if it's not safe to work, then, and if the risk is not controlled, then you don't work. Simple as that. The better idea is to obviously identify this before you go to the site or the area where you want to work and resolve that as quickly as possible. And at the end of the day, legal requirements are not just there to keep paperwork in place. Like you can see Saki over here, the legal requirements in real life is the actual thing that caught Saki, not the paperwork. The paperwork doesn't really matter. The fact is that you implement it and the paperwork only proves what you've done. And you can see everything that he uses here, these harness, the rope, the carabiner, everything, that sling, everything has a rating, and it's all part of his entire kit that he uses. So think of legal requirements as a kit that the employer and the employee can use to make sure if something goes pear-shaped, they are caught and nothing happens. Instead of if something goes pear-shaped, then you've got paperwork to prove that you've communicated to him and he was just stupid Saki. So that's a principle that's very important to me. So that brings us to the next thing. How do I control the fall risks? And there are three main principles that is very easy to implement. You can communicate this in all of your DSTIs or your risk assessment communications. Sorry. And that the first thing is, and it doesn't matter if it's an employer or the employee, but the first thing we need to make sure of is that we do not expose ourselves and others to harm. So, and that's basically the main thing of everything. The third thing is we make sure that we reach an outcome. In other words, there's a two-leg side of this duty. In other words, you have to reach the outcome where you go home safely. And the second leg is the outcome is I need to make sure whatever my task is that it's done, I can go home. So there will always be a two-legged exercise about this. Safety and production cannot be split. They are intertwined, and we need to make sure that we understand that completely. And the last procedure is, or the last duty is, we need to make sure that we follow procedure. Typically, in a normal safety conversation, the first will be follow procedure, so that'll be right on the top. The reason why follow procedures at the bottom of the three duties is the fact that I want the guy to think what he's doing. In other words, he implements the procedure with a mindset of he's looking around and he's understanding what he's doing. He doesn't just implement the procedure blindly, like following a GPS, and if the tunny on the GPS says turn left right here, and he drives into a wall. So, and I think we can all agree that it's an extreme situation or extreme example, but we need to make sure that all those people working at height are able to implement the procedure, but at the same time, remember the first two duties, not to expose yourself to harm or others, and you need to reach the outcome. So next, we'll have a look at unpacking those legal requirements. And again, this is international, so it doesn't really matter what country you are from. The concept is the same. There's an Occupational Health and Safety Act. It might be called something different in other countries, but the principle still stays the same, where the employer needs to provide a safe work environment. Then there are general regulations. In other words, if you are do something specifically like construction or machinery, for instance, then those regulations are then implemented. And then we see on the third one that the construction regulations and the machinery regulations are then specified correctly. And I think what's important for me is that if you reference something in your fall protection plan on a specific construction regulation or a regulation that the country requires, that means that entire regulation is then required to be implemented word for word in the fall protection plan. And I think there are some cases where the guys just reference it and then they forget about it, and then the risk is not really covered. So in South Africa, we've got, in my mind, we've probably got the best construction regulation in the world. It covers a lot of things. I've seen many other construction regulations over the world, and I think we're probably the top 3 when it comes to construction regulations. So that's the nice thing, is we can really trust our construction regulations to help us and maintain the risks for specific items. Then when we start using the items, we can then use European norm standards, we can use ISO standards, and then in South Africa you can use SAN standards. Typically, the best option for me is the EN standards, mainly because they've got an additional quality control measure on it. Most of the EN standard, I think all of them, they've got a CE control additional to the EN control onto that. So it's doubly enforced, whereas SANs only conform to SANs, and let's leave it at that. So I like the idea of a quality system that's enforced and it's checked by 2 independent authorities, and that's pretty awesome in my mind. So the chance that you will have a good equipment and with a good standard is very high when you choose an EN product. Right, now we need to go to how do I plan for fall risks. To plan for a fall risk is pretty simple, and it's, I think, for everything. Even as a rock climber, it still stays the same. I need to do a risk assessment, and during that risk assessment, I have to make sure that I identify the risks, I mitigate, I control them with the correct procedures, and I've got a plan in place to review those procedures and make sure that they are working. Secondly, you need to make sure that you are medically fit. So why medically fit? Because if you do suffer some sort of a internal medical condition, that may cause you to fall. So high blood pressure, low or high blood sugar, any heart defects, all of those things need to be checked by a competent person, and that is critical to our risk control measures. The third thing that needs to be in place is some training program. And I think from my side, it's very critical that you ensure that the training program you use fits in together with your fall protection plan. It's quite tricky to use different, if you want to control risks and you choose various training companies and you don't make sure that their training is aligned to your fall protection plan. And it's very risky because most of the risks are then controlled and the guys are trained to firstly see the risk and then exactly how to implement the controls by using the PPE correctly and then communicate and buddy checks and all those things are covered with your training. And it must be, as far as possible, speak to your training provider and make sure that they tweak the course a little bit to make sure that it's as per your task requirements. To give you an idea, we've specifically, in one case of many, we've changed our training program a little bit for whenever there's banner flighting. So that as part of his workplace assessment, we've got a banner set up in the office or in the training venue where the person actually uses those training fall arrest techniques that he's now learned and how to flight that banner correctly and safely in that same work environment, how to choose the anchor points correctly, what to do if there's a rescue that needs to be done, and all those things. So make sure that your fall protection plan and your training program, they are married together and that you've got the approval from your managing director or your CEO or your assistant to the CEO or your construction manager. You two guys or women need to discuss it amongst yourselves and agree on one set of training standards, and then you can move on from there. And the training will then specify the equipment. So a lot of times I see that people, they do the training, but they use different equipment. Some reason might be historically they've chosen a certain brand and they are sticking to that. But if you do that, make sure then, I'm saying from my side as a fall protection plan developer, it's very difficult for me to give persons equipment that they haven't received training on. And this is across the board. If you are going for your car license, you're only allowed to drive a car. If you want to drive a truck, you need to go for your truck license. Now, in my mind, that is the same with your personal protective equipment. Collective PE or collective personal equipment is now a buzzword in the industry, and that basically just means something that will protect more people with less effort. Like, for instance, if there's a flat roof, they put a hand railing around that and ta-da! The likelihood of you falling off the roof now is very small. It's unlikely. It's not guaranteed because you can still lean over the freaking hand railing and then fall off. So be careful when you look at your equipment and your PPE. It lowers the likelihood of the occurrence. Sometimes it actually stops it, but be careful when you do your risk assessment and you decide on the equipment you use. And then lastly, we will discuss a little bit further on the rescue side of it. Is the rescue that you choose applicable to you as a company and to the employee when he's working for that specific task? And here's the hot topic. So, is the implementation of the fall protection plan optional? So this is where it becomes a tricky scenario. And I think you'll all agree with me. It's not really optional. So if we discuss that for a quick moment, it's something that on paper seems pretty reasonable, that once you've got a fall protection plan, you read through it and you implement the requirements. So there are a couple of business obstacles that are in our way. So it's important that when you ask your manager or your director to sign that fall protection plan, please make sure that he understands the requirements. He understands that if you decide to change the route, then you will change the way that the risks are controlled. To give you an example, and I think it's a pretty extreme example of when you change SOPs. Some of you guys have seen the Chernobyl nuclear accident in 1985, or was it 86? I think it's around there. And if you read the events leading up to that disaster, in my mind, the biggest thing that they did was they changed the SOP. They were originally supposed to run the reactor at 1,200 megawatts, and they decided that they would go ahead with a lower megawatt reading or lower megawatt output, and of about, I think it was 250 to 340 megawatt. And that changing the SOP without then making sure that the rest of the SOP adheres to now their sudden change. All they did was they picked up the phone, they said, "Hey, Vladimir, what do you think? Can we carry on?" Vladimir said, "Yes, let's go." But in the background, their test that they wanted to do was basically done over a 2-month period, where lots of Vladimirs and Ivans and other people with thick glasses and white coats sat around a table, and they specifically worked out the test requirements with all the different limitations that they were aware of that specifically required this SOP. And now you change it, and then suddenly you have a world disaster because of one thing that was changed without checking back to the process that you were supposed to follow. And the same goes with fall protection plans. It's not a window dressing, it's not really optional. And if you do change it, make sure then that you speak to the fall protection plan developer and ask him, okay, why did you choose this specific harness? Or why this system? Or why did you choose Gravity Training or Saki's Best Training Company number 72 to do your training for you? Can I change it? Why can I not change it? So that your manager, you will be able to give your manager that informed decision, and then from there on he can make his decision. But from your side, you know the risks, so you need to make sure that you stand up to those risks and explain to the person or your manager exactly what is the reason behind it. All right, I think let's continue, and I hope you guys have some coffee and maybe some biscuits and stuff. The nice thing is I can't see you, so you can probably eat biscuits and nice other sandwiches. So cheers, good luck with your coffee, and I hope it's nice. All right, so let's carry on with our presentation, and we'll do some more slides, and we can see what I just meant with what our discussion just said. Right, so we all know the Swiss cheese effect. So the idea of controlling risks, as a risk controller, you want to be able to predict the risk that's going to happen, and you put measures and system in place so that when you predict something, you can put a measure in place. But no measure is perfect. There will always be a runaround, and I think we all know that even with our audits that the clients do on us, there's no audit that's 100%. I can go to any safety file, no matter where you are, there's no way that audit will be 100%, especially the second audit where you look at implementation of the actual safety requirements. So if you look at our Swiss cheese model, you will see the first one and the biggest one is if the fall protection plan is not implemented. In other words, management don't put their weight behind it, and you don't enforce or remind management of the actual risk they are exposed to if they don't implement it. So in this scenario, training wasn't done. Okay, and that's a very big hole in the system. So why is training so important? I mean, training is there to make sure that you familiarize the guy or the lady with the actual risks they are exposed to while working at height. You familiarize them with how to control that risk, what equipment to wear, how to make sure that they use it the correct way, how to implement buddy systems to make sure that they put the harness on the right way, As a rock climber, I can say that if it wasn't for my buddy rock climber, there are a couple of cases where I can guarantee you if he didn't correct my mistake before I started climbing, I would not be here today. And even with work at height, if I didn't implement the buddy system, there was one specific case I remember where I didn't close my leg loop properly. So you can imagine in a fall arrest event, if you don't have your leg loop closed, how big an issue that is. But because of the buddy issue, because it was trained into us in the training, we can stop that from happening. The second hole in the system might be unsafe use of PPE and systems. So again, that's part of training, but it might be that the system itself is inherently unsafe and the PPE itself is inherently unsafe. So again, that's something the fall protection plan clearly states on exactly how to do that, what system to use, and how to make sure that that system is safe to use. Second thing, we depend on our harnesses, our personal protective equipment. We depend on them so that they are there for a reason and they must fulfill that specific reason. If you look at the last Swiss cheese hole, you'll see if a fall arrest event occurs with all that other stuff in place, there's a serious incident, because now suddenly my damaged harness is supposed to catch me. I fall, I'm like, yeah, it's gonna catch me, and then poof, done. Then I've got an incident because my fall arrest system broke. And now that's seriously unacceptable. We cannot allow that to happen. So please remind yourselves, remind your managers, and really go through your fall protection plan and read it carefully to make sure that you understand these requirements that are set in place. And like I said, there are legal requirements, but it's not paperwork. Paperwork is just one slice of cheese in this whole freaking disaster event. The rest of the stuff can only be done by physically enforcing the requirements. All right, I hope it makes sense. I think we can move on. Jose, I found this slide in my earlier presentations. I think it was 2014 where I found this. And if you look at Saki there, he's putting up this massive safety board and he's totally ignoring all this stuff. He's really just, and this happens. You see a lot of times people standing on chairs if they just quickly want to put up a poster. But it's ironic, but in fact, this is what happens. Because he wasn't supplied with the correct equipment, he didn't have the right risk assessment training, and it wasn't easy for him to follow the procedure. So he just said, stuff it, this needs to be up, let me put it up. So if we look specifically at when it comes to implementing fall protection plan, it's important for me to make sure that if you refer to a specific standard, a EN standard, a recognized standard in your fall protection plan, like for instance, let's say EN 397, that's your anchor point standard. It's international, so it will go across Africa, even in South Africa, it doesn't really matter. My concern is if you reference that as a fall protection plan developer, have you read what it says there in EN 795? Do you understand what a Class A1 anchor is? So please be careful and please be wise that the moment you reference a standard, that means that you reference a specific standard word for word. And if you don't do that, then it will result in a generic plan. And generic plans are dangerous. The only way to make a fall protection plan site-specific, task-specific is with a good risk assessment and then good procedures then to make sure that you align your plan and you control the risk specifically. A lot of times we see that the fall protection plan is not aligned to the client requirements, and we don't read the client requirements specifically. So it's important that we really do that and make sure that the client requirements are read. They give us, most of the time, they give us opportunity with a kickoff meeting to discuss this, and we can hash around it, and then make sure that they understand that the client requirement, or we understand the client requirements. Just as a footnote, please be careful of client specifications, because client specifications generates evidence. It does not check that your system is good enough to generate the evidence. All they're asking for is the actual evidence. So be careful of client specifications. Make sure that your system that runs in the background, that fall protection plan machine that runs in the background and spits out risk assessments and procedures and proof of communication and all those things, that system is correct. So we've kind of like a flawed system, because our client specification just asks for evidence. They don't really check the machine running in the background. And that's why we as fall protection plan developers must make sure we check that machine. If the machine is faulty, it will look like the machine works with the evidence, because that's all the client requirements. But are the risks really controlled? No, we just have paperwork evidence. And I'm really, really adamant on this, that we need to make sure that that fall protection plan machine is designed properly, it's well oiled, and it's maintained. Then we've got and the best way to do it is by doing a proper risk assessment. Make sure then that if you do have if you're not sure about something, contact a subject matter expert. Like if you're doing rope access, make sure you contact a rope access person. And the rest is the same. Scaffolding, for instance, I think that's something that needs a lot of attention. That we reference the SANS codes, for instance, or the EN code in our scaffolding, but we don't make sure our inspectors and our erectors and our supervisors properly follow that SANS code. So again, it will seem like we doing the right thing because it spits out nice safe to use green tags, but at the end of the day, the evidence behind it, then the machine is not working properly. So be very careful of that. Right, so let's have a look, and please make sure that you understand the process of, you start with your work at height risk assessment, then you go to your issue base. So the work at height risk assessment is for the entire site. In other words, that's the expected risks that you are expecting due to your scope of works. Then before you start a specific major task in an area, you go to your issue-based risk assessment. There you will look at, okay, I'm in this area number 72 or 51, and this specific issue-based risk assessment covers this area that I'm here in for the next 2 weeks. Then from there on, you've got your daily risk assessment or your pre-task risk assessment, and that will be your DSTI that's filled in daily by a competent person, and it's communicated correctly. So, but without the issue base, you cannot link the DSTI to your work at height risk assessment. So be careful. This is a loop. This is a step. It's like driving in your car. You can't freaking drive the car if you don't start it. So work at height risk assessment is starting it. Putting it in gear is doing the issue base, and the DSTI is actually being driving and making sure that you are doing the task of driving your car. All right, so the next one is we'll have a look at it a little bit later in terms of rescue plans, but be careful of inclement weather. It's a great topic. So when we discuss inclement weather, it's one of those things that's very difficult to control from an actual desktop, because we ask our foreman to make a judgment call. what is inclement weather? And it really depends on the task that we are doing. So the definition of inclement weather is that the moment the work is unsafe, the work environment is going to be unsafe, because that's what it makes it really tricky. It's not as easy as using an angle grinder. You can pretty much say, okay, sparks are going to come now. But with inclement weather, with lightning, you can't say, no, it will start now. It will start with lightning and then I can take the guy off. So you have to make some sort of a judgment call in terms of what does the weather look like? What is the experience? What am I doing? And you have to plan ahead before you can say, okay, now, okay, guys, it seems like there's dark clouds approaching. What are we doing? Are we doing a lift? Are we just doing an earth cable inside a lattice tower, inside a cage ladder? So the task and the area and what you are doing really influence the decision on when you're going to declare inclement weather and what time frame you are going to choose before you implement that. And it's something that can't really be done on a desktop. There's so many different things that the site supervisor must take into account before he can declare the site to have inclement weather and now I must stop work. So it's not only just about the inclement weather, it's also about doing the actual rescue. A lot of times the guys are so focused on doing the work that they forget, wait a minute, if Saki falls now and I need to do a rescue, my rope is going to run horizontal with the ground because of the actual wind that's blowing. It's going to get tangled in the barbed wire or the anti-bird stuff or whatever. So please make sure that your supervisors in their decision making, in that informed decision, they can actually decide on, oh, wait a minute, inclement weather. Okay, so it's not just about doing the task safely. It's about making sure that I can still do the rescue. It's about planning ahead and to see, okay, wait a minute, when will this actually happen? And that time frame that's in there is not something you can put down. And I'm saying it a lot now, but I want us to please make sure that we understand that. And then we have to trust our site supervisors to make that call. We have to put a system in place to make sure that they are then properly trained and experienced to decide when is inclement weather actually going to be affecting us in terms of fall risks or health and safety. Right. Okay, I think that's clearly discovered. I think there's a lot of questions that could be asked about inclement weather and how do I predict it and when is lightning actually lightning, and there's a lot of research that suggests that if you look at golf courses but at the end of the day, it's still inclement weather. It's not really predictable. The only thing that you can do is you can say, oh, something is coming, I need to prepare. If it hits this is my cutoff point. If I'm doing a lift and the wind is over 7 kilometers an hour for a specific surface area, I need to stop immediately the rest. I need to make sure that my lifting plan is then adjusted to be able to stop at that stage, or to be able to finish quickly and secure the load before the wind exceeds a certain amount. So make sure then that your inclement weather risk assessment is done properly. Right, if we go back to the actual slideshow, we will see there's a night work option there, and night work is also a kind of a tricky thing. It's a lot like inclement weather, and please note the requirement doesn't, any OSH Act won't say that you're not allowed to work at night. What it will say is that the right lighting conditions must be there so that the employer can see how to do the work properly and how to identify the risks around it. On a lot of construction sites, you'll see night work happening, sometimes inside a monopole, for instance, where it's dark. Technically, that's night work. So you have to have personal lighting in there, a proper lamp to make sure then that that specific task that you are doing there has got the proper light conditions for you to do the task. And I know in the South African one, we've got, I think it's in general administration requirements, there's a specific lumen count that you have to do, and you can use that as a guideline. Not can, you actually need to do that. But again, it's depending on the task and the risk. So in most cases, they, especially I think in the telecoms industry, they exclude night work completely. It's because they say it's just there's too many incidences in the past that stopped or that occurred during night work for various reasons. But it's still not impossible to do night work. For instance, I can give you another example. I know on the mine specifically, they've outlawed all rigging slings, like textile rigging slings. They only allowed either chains or wire rope. Why? Because they are using hot work, they're doing hot work, and there are a lot of sharp edges, and they've just had way too many incidents. So they said, okay, Saki, please leave your textile sling outside, and you're not allowed to bring it in because we've known there were too many mistakes. The guys didn't do proper risk assessments. So in our scenario, we will not allow textile lifting slings in place. So that gives you kind of an idea of how to work with night work. It's generally not agreed upon, but it still doesn't mean that you cannot do it if you have the right risk assessment with the right controls in place. Then that's the same for rope rigging. There are certain standards and requirements, some training requirements, specifically some supervision requirements. And then lastly, we'll have a look at ladders and scaffolding. And again, there's specific standards and regulation that according to which you need to do your ladders and use your ladders safely and your scaffolding safely. So this is something specifically in South Africa. The scaffolding standard is SANS 10085, and very few scaffolding inspectors remember what stands in that actual standard. The pictures are a bit bleh, but they are busy refocusing on a new one with better pictures, but the principles inside there will stay the same. Doesn't matter if it's next year or the year after that. The principles of safely using scaffolding must be according to some recognized standard, and then that standard will be the machine that you use to control the scaffolding, and that machine will then spit out the correct evidence that you've done the scaffolding correctly. You've got your scaffolding tag, you've got your handover certificate, you've got the purpose and the square meter, kilogram per square meter that you're going to use it. So again, please remember, it's about the machine that spits out the evidence, and it's not about the evidence itself. Right, so I think let's discuss some event triggers regarding fall risks. It's quite funny. My wife is a script writer, and I asked her about how do I write this event trigger. Well, is it fall risk and event triggers, or is it event triggers fall risk? And as a script writer, she said, no, Johann, this is the better way to write it. So it's event triggers that will cause fall risks exposure to your team on site. And if we can just discuss that face to face quickly, we can discuss it, and we'll see what are the different event triggers. Typically, I think for the first thing is we need to understand that the site itself, it's got its own specific risk event triggers that will cause a specific thing on site, will cause a fall risk then to be there, and then a person or an object can fall. a task, for instance. Like if I use a 9-inch angle grinder on the ground, and now I use that same 9-inch angle grinder in a full rest position with my work belt attached to me. Now I'm grinding and there's sparks going everywhere into my system. There's hot metals and stuff. And so it's a completely different scenario than doing it on the ground. Now you can imagine doing it on rope axis work. So that adds another addition to that. Does it mean I cannot do it while doing rope axis? No, it doesn't. It means that you need to control the risks. So the rope axis guys have got some Chinese tricks. They use a perspex pipe that goes over the rope. They always cut below them. So in case something happens and the grinder gets caught somewhere, that it won't cut the ropes above them and they will still be safe. So there's a lot of controls you can put around it, but please be careful when you do your risk assessment. Make sure that task being performed at height will then be controlled properly. It's about the environment. I think we've discussed that, and how the environment can change, how quickly it can change, and where is our stop work cutoff? What is the stop work procedure? And that's something we might look at in the future, of adding that into our fall protection plans in terms of what is the stop work. When do I decide on stopping work? Oh, is the answer is when it's unsafe. Okay, what does that mean? So that needs to be discussed with our work group and deciding on when. We need to look at the people we are using to complete the tasks. Are there a bunch of engineers who haven't really read the full protection plan, but they still need to go do and make sure that the actual item is then ready for to include it as that it's ready for startup, for commissioning. That's the better word. Yeah. The work platform that they are using, where are they working from? Are they working from a scaffolding platform? Are they working on a cast concrete platform with open edges? That work platform can also then affect their fall risks. Access method, is it a ladder? Is it scaffolding? Is it a rope access? Is it a cherry picker or a mute? Is it a suspended access platform? Is it stairs that opens up to a specific area? So those things need to be thought of. The kind of equipment that I use, and this specifically goes back again to my training. Please make sure that whatever equipment that people use, they've received the correct training in. And that's super critical. What are the safe work procedures? And the safe work procedures are only really effective if you remember the 3 lines we talked about, that you've got a duty to make sure you don't expose yourself and others to harm. You've got a duty to make sure that you reach an outcome which has got those 2 legs on it. The first one will be the safety, and the second one will be the production side of it. And the third point we're looking at is we need to follow procedure. And the only way to follow safe work procedures is by intelligently thinking about the first 2 duties while we're implementing the procedure. Because it's not about the procedure, but it's about the principle that the procedure wants to control. And lastly, the work at height equipment and the PPE. Make sure then that your PPE will then be specific as per the training, and make sure that it's correct for the task and the site, and not just the work, but remember there's a rescue component behind that the PPE needs to be compliant with. I've seen a lot of harnesses that's got a flat buckle with the shock absorber attached to that, and that's typically not wrong. It reaches the EN code or the SANS code. However, if I do a rescue, there's no D-ring to connect my rescue system to it. Now, what am I going to do? Where am I going to attach that rescue system? I don't know. Do I make a knot? It's really difficult. So make sure then that the PPE that you use is the correct type. If it's not, go to your training provider, which is like pick us because we want to, but in general, make sure that you have some sort of a workshop where you can work around that PPE. The best solution is get the right PPE in the first place, and you don't have to fuff around with the workshop, because now tomorrow Pity comes to work for you and he hasn't done the workshop. Now something happens. Do you see how it starts to escalate and it becomes really tricky to manage? So the event triggers, if we can quickly look at the slide again. Thank you for Yandre being our producer. It's kind of a snazzy word. So there's the things we discussed: the site, the task, the environment, the people, the platform, access methods, equipment, safe work procedures, and work at height. So we've got some published questions. If I go back, would you mind if we just quickly carry on? I think I've got a specific space. We're now on slide 15. So we've got a nice question on night work. There's a question here on night work from Hannes that says, night work has also slippery conditions due to wet surfaces. Yeah, in South Africa, especially depending on the time of the year, if there's dew on the structure, yes, that definitely adds additional risk that needs to be controlled. And if it's slippery and you can't control it, then we go to the last option and we don't do the work. And that's probably one of the main reasons as well, where telecoms guys said, okay, we don't do night work because we can't control when it's going to get wet or not. But if we can control it with a proper risk assessment, there's no reason why not to do it. So I understand what Hannes says is that we need to make sure that we check all the risks and not just the actual lighting itself, but there's a whole lot of set of risks that goes around that. Our second question is from Benny. And he's asking, is there a specific reading kilometers an hour as to when work must be stopped? Wind forces, for instance. Yeah, that's an interesting question. And from my side, again, when I'm doing lifting, we have to look at the surface area. In our mechanical lifting, the training that we do, we have a nice formula or a system that helps you calculate the actual wind loading on the surfaces that you are using, and also includes the tag line, because remember, the moment the wind pushes now on the device that you are lifting or the item, the tag line holding it in place, that load is then transferred also to your top anchor. So it's not only the wind loading that's affecting it, but it's also the tag line that adds additional load to the top of the anchor. So you have to decide, what are you lifting, what are the conditions, what's the safe working load of your system, what is the safe or the working load limit of your tag lines, and all those things need to be in place correctly. So in general, there are, for rope access specifically, internationally, they're looking at about 39 kilometers an hour, which is roughly 10 meters per second, which is 36 kilometers an hour actually. But in general, they're working at 39. I think it's got something to do with knots, the speeding behind it. But anyways, so that's the general rule. If you are lifting, you have to do a proper rigging plan. I can't tell you, no, 3 meters a second, or now I think 5 or 7. It really just depends on the actual work that you are doing. And remember, what if something goes pear-shaped? How long do I have to secure my object? So if the wind does increase, is this area known for the gust, for wind gusts? So I need to make sure that I take that into account as well with my risk assessment. So it's very important to do a proper rigging plan and a proper rigging study, where this is one of the questions that you will look at. I've got another question here. When we are doing rope access in South Africa for telecoms, but not in the rest of Africa. So that's a good question, and I think the main reason for that is that fall protection plan developers don't see rope access as a access method, as a proper access method. We are so used to using scaffolding or ladders or structures that we don't see the advantage of using rope access. And there's a lot of advantages behind that. But who's responsible to decide that? The full protection plan developer. And he needs to then contact a specific rope access expert that will help them. And I can tell you there's many cases where rope access is a lot cheaper, a lot faster and safer to control, with a lot, especially in Africa, with fewer variables in place. In Africa, the building maintenance units are a big thing, but if you think about a control behind it and the amount of inspections and the conditions that it's being stored in, the rope access, once it's done properly, it's a lot more versatile than your building maintenance unit. And it's something that we need to kind of just open our minds to see. Rope access is a very good alternative to BNUs, and it gives your cleaning squad or your maintenance team more options. I can guarantee you there's building maintenance units that won't get to specific areas, and those specific areas will always be an eyesore, and it's not ideal. So remember, there are bigger advantages and there are also disadvantages. So because rope access requires more training, but it's in terms of when it's done properly, it's safer than the BMU, because the BMU itself also then has got mechanical parts that needs to be maintained, and difficult conditions in, let's take cities next to the coast, Dar es Salaam, for instance. That building maintenance unit is exposed to a lot of environmental factors. And then a specifically very competent lifting machine inspector, specifically certified as a building maintenance unit inspector, must then inspect that actual building maintenance unit. So I think the idea is keep your minds open and realize there's a very nice tool that's hiding behind something that you can use properly and very effectively in a shorter time distance, and a lot more effectively than the current systems we are doing. We will discuss, there's a question about rope access work. What is it? In simple terms, it's a person coming down a set of ropes, and then one rope is his work positioning rope and one rope is his backup line. If something goes wrong with the first rope, then the backup line will catch him. So the important thing is to make sure that the person trained on the ropes is properly trained how to go down, how to come up safely. And secondly, if there's a guy next to him, how does this guy then do a rescue to Ppe now? And then obviously the biggest thing is managing the site on top, where you use your anchor points, and at the bottom, how do you control the drop zone, if you want to call it that. Right. I think we can go. There's some other questions, but let's carry on, and we'll ask those other questions a little bit later. Okay, so if we go back to the slideshow. Okay, we've discussed this one. We had to talk about rigging. We'll do some extra questions a little bit later afterwards. I think I want to carry on with a little bit of more details. We're already an hour and 15 minutes into it. So I hope you guys can also take a quick coffee sip here and there. And then let's carry on with the actual slideshow. I like this specific picture where it says don't run, you're gonna fall into stuff. Okay, and beware of deep shafts. And the last one is it says don't walk backwards. You've got a guy there taking a camera, but from personal experience, as a person working at height, you need to be spatially aware. And that's one of the things that can cause a lot of injuries and a lot of damage if people are walking backwards and they're not aware of the risks. I myself personally have been exposed to that, especially when it comes to fragile surfaces where you need to barricade it properly. And if it's not barricaded, then it's really difficult to see that risk. Okay, the idea is actually to barricade it, but you understand what I'm saying. So walking backwards in a work at height environment is really a bad idea. Right, so let's move on and we'll have a look at the different specific areas where we can protect people working at height. This is from a company that we are partnered with. They are called Fall Protect. In this specific picture, they have this cool setup where they can put up a hand railing that's got some dead weights, and I think there's some glue system also involved. And then they can put up nice walkways. You'll see there by point number 2 and point number 3. And even on beam cranes, you'll see that there's a nice walkway on the beam crane. But what I wanted to show you is on this specific picture is, okay, how do I control a fragile surface? Best way is put up a hand railing. Inclined roofs, what do? I can put a lifeline on the top and I can make sure that I'm attached to that lifeline so I don't slip off the edge. So the big issue is not really falling on the roof. The issue for me is falling, slipping and sliding. And then when you get to this point at the edge, like, what? There you go, socket falls off the roof. The second thing is there's an open area there. And what they do is instead of making it a massive system like that, they put separate individual anchors on the edge of the roof, a specific point away from it. So then Saki will probably mainly maintaining, looks like there are some purlins or ribs hanging there that he's probably going to maintain for some reason. He needs to paint them or whatever on a regular basis. So we've got individual anchor points on that roof, and it can be any kind of roof. There's a lot of these guys from Fall Protect have amazing systems in place that they can put anchor points on a roof a specific distance from the edge. You'll see there's a nice rail system where the guy climbs up with a ladder, attaches himself to a pulley, a trolley, for instance, and he can move left and right, either like Saki is standing there, or he can be moving on rope axis left and right. There are systems that if you have to work in a sump area, they're close to the number 3 point. There's a system that if something goes pear-shaped, Saki can then be lifted out of that sump area because there's no other way of him exiting the place if he's unconscious, if you don't have a specific lifting system that will lift him outside of the sump. When you get to confined spaces and there's a specific tripod that you can set up and that you can put in place to make sure that you can lift the guy out of that area. And I like their truck system where, again, it's on a rail system, but now you have this amazing, you can put your not shock absorbers, your retractable lanyards to that system. And this can either be a fixed system or it can be a portable system. So you can see, in my mind, there's many different ways of protecting against fall risks. And if you have a engineering bay, you'll see there it looks like toilet roll there. Everybody's now looking for toilet rolls in the COVID environment, but Saki over there, you will see is also attached to a rail with a trolley. And then if something happens, then you will be caught on that system on a retractable lanyard. And we'll look at the rescue a little bit later on terms of how are we going to rescue that guy. There's a horizontal lifeline system on the end of the crane there where Saki can do maintenance if he's an electrical expert and he's maintaining the electrical contacts of that breach crane. So for any thing that you can think of, there is a system, any folders, there is a system that will protect you against it. So first of all, we have to decide, do we put up a hand railing, because that is the collective protective equipment that will protect the most people, or do we put up a lifeline that will protect only one guy who's connected to that, or two guys who's connected to that? And that's something that you will have to think of in your risk assessment and discuss it with your director or your project manager in terms of the expenditure behind it, and is it a high volume area, etc., etc. So I like this picture. It shows a lot, but it also shows you how you can manage your fall risk environment. Right, so there's the theoretical part of it, and if we go forward, then there's the actual part of it. What it looks like on a construction site. What are our access methods? We've got a nice cherry picker there. You'll see there's a working platform up there. There's a scaffolding, there's ladders, and even on a smaller scale, there's a loading bed there. How do you get on there? It doesn't need to be 3 meters. A lot of discussions in the past asked that, okay, how high, when does it become work at height? The answer is easy. If there's a fall risk, it is work at height. That's as simple as that. Then you have to do your risk assessment, decide on your medical, your training, your equipment, and your rescue environment. So in a full protection plan, it will specifically say, for instance, okay, cherry pickers to be used as per manufacturer's requirement. So therefore, make sure that you have the manufacturer's safe use requirements. Make sure then that your controls are being operated from the top. The first plan B that's in place is Saki at the bottom goes to manual override, and he will then lower the men on top. He will lower them down. That's your first rescue. If that's not possible, then you have to have some sort of an escape rescue kit at the top where you can just abseil down. And again, it will depend on your task and your environment and the competence of the full protection planner on deciding on which one he chooses. What kind of ladders do I use? How do I secure them? Scaffolding, and then that's all part of it. So on a real site, you'll see there's a lot of things there that you can work from. There's a lot of different situations. What about if Saki's working on the edge here and he falls down? Now he's hanging in the air. How do I rescue him? That's something to think about. We'll have a look at it just now. So you can see theoretical controls versus actual controls. It's different, and we need to be experienced in how we do it and tweak our full protection plan, our rescues, our risk assessments to make sure that if we do it, it is still applicable and it's still valid for the site we are working on. And then make sure, even if it's a small scaffold like this, that looks like it's 1.5 meters, it's still scaffolding and it still needs to be controlled as per specific requirements. Right, what can go wrong? Okay, there's our managing director, Barry. I think most of you guys know him. And he's looking at Saki and he's like, fate Saki, what are you doing? Okay, so, but Saki is doing rope, or he's actually doing rock climbing. So let's see in the real world what can go wrong. Right, so you guys have all heard about fall factors. So when I'm climbing a structure, the ideal thing to do is, if we look at the first picture over there, there's Saki. Maybe it's Ppe because he's more clever than Saki. He's climbing up a structure and he's making sure that he stays in a fall factor that is about 0.5. In other words, his lanyard is 1 meter long and he will fall only a 0.5 meter. So that gives us a 0.5 of a fall factor. A fall factor of 1 is still acceptable. Let's say his lanyard is now 1 meter and he will fall 1 meter down before it starts activating. Then Saki starts to come here and he's got some Chinese tricks and he starts to climb higher than a fall factor of 1. You can see there's a big question or big exclamation. So Saki needs to be careful now. What he needs to remember is, if he starts falling now, there's going to be a shock load. But that shock load will then deploy his fall arrest device, and he will need more space for that fall arrestor to actually catch him. And now Saki starts to do silly things. He goes into a fall factor 2. In other words, he's got a 1 meter or Lanyard in this case, and suddenly now he will fall 2 meters. So 2 divided by 1 gives me a fall factor of 2. And that is becoming very serious. There's a big shock load that's going to be on the system. Can my anchor point take that? And additionally, remember now, my shock absorber will start to deploy even more. It can deploy up to 1.6 meters, for instance, or 1.5 meters. So he really needs a big area below him that's free and clear of any obstacles. Most likely, Saki will hit some sort of a bar below him. So in training, we specifically train the guys to never go above fall factor 1 and be very careful of 2, but never ever get yourself into a position where there's a fall factor of 2. What we don't tell them is that the shock absorber is designed to take a fall factor of 2. So it's not like he's going to die. You'll see there's only exclamation marks. It's not like Saki's going to die. It's designed to take that. If you're weighing 100 kilograms and you fall in this position, all you really need to worry about is is there enough free space to catch you? And then the last picture, Saki, and I think they call it a Jolly Roger. That's this skull and crossbones, which means death. Now, what is that? That's sliding anchors. You'll see now if Saki falls, it will be a fall factor of 4. In other words, he's going to slide a couple of meters before his shock absorber hits the bottom. Then he's going to fall his 2 meters. And then he's going to fall another 2 meters. And then it's going to start deploying. So to be a factor 4 fall, technically he will fall then 8 meters in total, but with only a 2 meter Lanyard. And there's no system in work at height that will actually take that full factor of 4, and you will be dead, guaranteed. There are some case studies where this happened and the shock load was so much that it actually uncoupled or unhooked from the diagonal section, and the guy fell in any case to the ground. So be very careful of that. All right, so my producer is quickly asking for a 5-minute break. I think we've got half an hour left, so let's have a 5-minute break. I will leave this slide there for you. You can look at it, you can ask questions for it, and then we'll be back in 5 minutes. Thank you, everyone. Okay, welcome back. I had some coffee and took a body break. I think my producer also took a smoke, which is good. So now he's fresh again. It's an interesting story. Last night I showed my wife one of my sound check and visual check video clips, and she was like, "Okay, Johann, don't move your eyebrows so much when you do this because it looks really weird." I'm like, "Perfect. Okay, so I'm not going to move my eyebrows too much, hopefully." Yeah, so my wife is in the movie industry and writing scripts and stuff, so I really appreciate her advice. It's my first time with this kind of thing, and I think we're having a good time. So in this last session, what I really want to do is there's three things that I want to really discuss. I think we need to touch on rescues and make sure that our rescues then are specifically designed to make sure that they are site and task specific. And we'll have a look at some pictures on that. The second thing I want to look at is some equipment inspection questions that we've got that I want to address. And then the last thing I want to look at is the questions that you guys have filtered in. So if you please will permit me to go quickly to the rescue section in my slideshow. So we're now on slide 19 with this 4 factors. And I think this is a very good picture that you need to make sure that you've got that in your mind. And when you do site walks, please be careful of this. And make sure the guys stay between 4 factor 0 and 4 factor 1. And especially when they are working, they need to make sure when they are working that they're as low a 4 factor as they can, preferably as close to 0 that they can. But if they are starting to work, they must not be in a bigger 4 factor than 0.5. Otherwise, things are going to become tricky. So we'll quickly go to the slideshow. And if you are scared about flashing images with me scrolling quickly behind through the slideshow, you can close your eyes and then we can start discussing some of the rescues. Okay, sorry, I need to go back. Okay, let's quickly discuss this because it also impacts on my rescues. Unsafe use of PPE. So what happens if you do fall? All right, so there will be specific rescue scenarios to this. So in the left-hand corner, we see what we call a fall down, which is Saki thinks he's safe in work restraint and suddenly goes to the corner and then what? He's on the floor. Okay, so please be careful. There needs to be some sort of a danger zone there marked out on top of the building. You can do how you want to do it with cones or yellow tape on the floor or spray paint or anything like that. Then the second thing is same story. Saki goes out with his restraint system or his retractable lanyard and he falls off the beam and swings back. And this is quite a heavy swing. So you can get seriously injured with this. So Saki's got the fake idea that he's safe there, but he's not safe. If he falls off, then he's got an issue. And then my favorite one, at the bottom left-hand corner, you can see Saki there, and there's not enough free space for him to fall, and then he will hit the floor and he will break his leg, and the floor is called dog. So please be very careful of this scenario. As a fall protection plan developer, one of the things we need to make sure of is the height of the anchor point. And when we do control the risks, we must make sure that the anchor point is high enough so that it doesn't hit the floor. The second thing we need to make sure is that the length of our shock absorber, we can lengthen it and shorten it as per manufacturer. They supply us with different lengths. And then the last one, if you have lifelines installed, make sure then that as well you've got specific danger zones or no-go zones on the building on the top, if it's a flat roof or wherever. And if you don't have those danger zones, Saki will be busy. Maybe he starts walking backwards and then again he falls off the building. And now you can imagine that tricky rescue. Saki is now hanging there halfway there. How do I rescue him? Okay, so please keep this in mind And again, that's why we have training. So we look at we train the guys to be aware of this. And then sharp edges is also important. You can imagine if there's a sharp edge there, IBR on that side, if Saki falls over that side of the building, his rope will break. And then that's it. That's the end. Even we've got a lot of procedures in place, Saki is still in danger. And on this one, you'll see there's some lifelines. Again, we have to decide, it's the full protection plan responsibility. The height of this lifeline is then good enough, so if Saki does fall, that he won't hit an obstacle, and there's some clearances depending on the site. If it's 0.5 meters or 1 meter, that will be then be adequate for him. So we decide, if you put your signature on that appointment letter, you are saying the lifelines will be safe enough that Saki won't get injured. Okay. If it's not, then you have to make sure that you do other options. And if you look at on the right hand side of the picture, there's definite no-go areas there for this inclined roof area. If he goes to the edge, he'll fall off and he'll probably cut his rope. So, and it's important then for this specific system to use a no-go or dangerous areas. And again, marking it is quite easy. You can put tape or whatever, even nylon ski rope on the sides to say, listen, this is the edge. You don't go farther than this rope is indicating. To remind Saki that if he's painting, he mustn't go to the side and he must stay on the one side. And if he does have to go, there's a different system that he can use as well, where there's a rope that's attached. Basically, it's almost like a horizontal lifeline that's attached at both sides. So if he does fall, he won't fall over the edge. So again, you can see there are many different systems, and the harness and the retractable lanyard is not the only system. So make sure that you use the right system for the right task. Okay, the next picture I want to show you, again, it will depend on my rescues as well. The two big no-nos for me is, the first one, you'll see there's a picture there that says danger. Now, this happens if Saki connects his shock absorber at the bottom D-link. You can imagine what's going to happen. Your center of gravity is very high, so when you fall, that shock absorber will not deploy. You will just flip over backwards and you will hit your head dead. Okay, or if you don't have a helmet on, you'll get serious injuries if you do have a helmet on. And then the last one, and I see this on site many occasions, where they have got one shock absorber attached to a anchor point and the one to the D-ring on the side of the harness. And you can imagine what's going to happen. If you fall now, that's going to start stretching or deploying, and suddenly you are hooked on your side and then you will break your back. So make sure that this is released on site. Please be very careful of that. And you'll see there also on the unsafe picture there, right at the bottom, the guys, if they don't have the right shock absorber, they connect like that. Now, what's going to happen? Those hooks are going to break. They're going to roll out. And if you unhook one, then you've got no point at all. And the principle is, if you are connected, you must always have one point. So now, if you connect the hooks together, it's just... And this is specifically a case if the guys weren't provided with the right equipment. So here, I would definitely say it's a full protection plan developer's reason to step up and make sure this doesn't happen. Reason number two, they hook the shock absorber back onto itself. And the manufacturers clearly state, don't do that, because if you do, you will break your connector and you will still then fall to the ground. So as full protection plan developers, we need to make sure that if there's a need for a sling, we provide them a sling. Or option number two, which is way better, we provide them with a shock absorber that's got a specifically designed fold back or wraparound function that it says from the manufacturer you can hook onto this little loopy, it being either material or a D-ring or whatever. So I don't need to carry a sling with me at all times. Right, so please be careful of this, and when you do your site walks and when you write your plan, keep these in mind. It's in the training manuals and it's stressed, but I can't stress it enough. this is high danger where it creates a false sense of security. Right, okay, so now that's discussed, then we can quickly skip to that and we'll go to the rescues. Ha, here we go. So technically, this is the rescue system that we are using. And the reason this picture is on and not a newer one, because I wanted to show you that this is one of the older pictures that we've done when we first started using the ratchet strap. And this strap is actually rated as an EN 543, which is a adjustable Ppe Lanyard. All right, so it's actually designed as personal protective equipment against falling from height. And it's been tested and rated. It's not just something that's just cobbled together in a backyard with some clever trucking guy. So, but this ratchet system has got specific limitations. There needs to be an anchor point on top, and you need to be able to reach the patient. Then you lift him up a little bit, unhook him, and then you can lower him down. Right, so that's one scenario. Then we've got a second scenario where a guy falls on a retractable lanyard. How do you get him off? Okay, there's a specific system that you are trained. This can also be used as a lifting system if Saki is stuck somewhere below. Right, so if you're in this scenario, make sure that you organize a workshop with your training provider or additional half-day training where you actually train this with the training company. Okay, so we've covered ratchet rescue for simple lifting a little bit, typically about 200 millimeters, and then lower down. Then we've got some sort of a pulley system that will lift and release the patient, also just either lift him all the way or lower him down. Now, the next scenario that's quite tricky for me is this. What happens now? Now, you can't reach the patient, so how do you get to him? So this is specifically where you need to get a link stick where you can attach your ratchet rescue to him, and you use a link stick to connect it to the patient, so you can lift him up a little bit and lower him down. But you can see where this starts becoming tricky. If I don't have an anchor point on top, what do I do now? Now I only have, let's say that's the one pipe that you have. It's still a link stick one, but now it becomes tricky. How are you going to do the rescue? All right. So we've developed the rescue to work even in this scenario, that you've got enough free space, even if you do connect there, to be able to lift the patient up and lower him down. But this is something that needs to be practiced. You can't take the standard normal rescue system, because that's not what's trained. Okay. So make sure then that you discuss it with your training provider so you can train this if you've got a specific scenario where this is in place. Next rescue, this is one we developed specifically for the monopole, for the telecoms industry, and it's a task-specific rescue. Now, there's a lot of limitations in here and a lot of risks that needs to be assessed before you can do this kind of rescue. But again, it's something that is available, that's task-specific, and area specific, that your training provider or Gravity especially can help you how to discuss this and to see if it's feasible. Monopoles is very tricky to control, and you can see here at the bottom where it says correct training is required before executing any rescue, and specifically for tasks specific rescues, where you not only need to do the rescue in the training, but then quarterly rescue exercises, because 6 months from now, the guys are going to really struggle to do this. Right. Something we do in our normal rescue, we've got this rescue procedure laminated and inside the rescue kit. So if a rescue happens, Saki can quickly pull out that laminated process, step 1, no, step 2, no. Okay. So it doesn't matter where he is, the rescuer will always be quickly reminded with a nice flashcard on how to do the rescue. Okay. So here it becomes a team rescue. Now, very few fall protection plan developers actually think about it. If I'm on a construction site like Kusile, for instance, which is a major power station. Some areas you will be required to put the patient in a stretcher and actually lift him up to a next level. So he was rescued with a basic ratchet rescue, and he was deposited somewhere on the ground, and now the rescue team must actually lift him up. So is this the responsibility of the full protection plan developer? Well, let's think about it. Is it a full risk? Yes. Is full risk part of his requirement? Yes. Is rescue part of his requirement? Yes. So we need to speak to the subject matter experts and make sure you've got proper rescue systems in place to be able to lift the guy with a proper system. Some of the sites are lucky, they've got a tower crane and they can use it, but it's always, again, it's something that needs to be risk assessed, practiced before you can actually implement it on site. So it starts to get really complicated. You can look at the next one. Holy cow. So now we've got a funny system that happens. And again, it can be something inside a boiler. He's fallen on one side and you need to lift him to move him to the other side. It's a tricky situation where you need advanced rescuers, advanced full risk rescuers to be able to perform this rescue, and it needs to be practiced regularly. And then lastly, holy crap. So now what happened? There was a structure failure, there was a cherry picker that fell over, and now they've got a lot of issues there. To make the issue worse, they've got rear attachment harnesses, and you can see that guy is not a happy camper. Okay, so by having a system there, they could have helped themselves a lot quicker to just abseil down to the actual structure. So we need to be prepared for that. And rescues are super critical, and it's also part of our requirements. It's what we are appointed for, and we need to make sure that rescue is then implemented immediately after the rescue. All right, I think we had a quick safety bulletin that discussed equipment inspection, and we'll discuss that a little bit later. We can send it out to you. We're running a little bit out of time, but I want to cover specific questions that are posted. So technically this is the end of my slideshow. There's Alex Arnold again, and he's seeing, okay, great job, well done. I managed my risks, even though I'm being a little bit stupid and looking over the edge, but my risks are managed. So if we go back to our questions, and there's me again. So let's scroll down the questions. All right, there are some rigging questions that says, what happens if my load exceeds 70 kilograms? The rope rigging procedure says I can lift up to 100 kilograms. The reason for that and not more is because your taglines add additional stuff, and your safety rating of all your equipment that you use, specifically in rope rigging, they are typically limited to 150 kilograms in most cases, sometimes 100. So it depends on the equipment that you use. So Balaji, make sure that you've got a proper lifting plan, and then that you make sure that the weakest link in the chain can still take the load, plus the additional wind load and the additional tagline forces that are working together before you start your lift. And then when you do a proper pre-lift, that will help you. All right, the next question we have, do we have predefined guidelines for working at nights? Again, we don't have predefined guidelines. The guideline we have is do your risk assessment, make sure you adhere to your client requirements, and as an employer, you need to make sure that the guy can do their work safely. Is there enough lighting? Does he need personal lighting? And lastly, is the lighting enough for him to see the surrounding environment, the surrounding risks? Can he see the guys at the bottom? So all those things need to be taken into account, and the only way to do that is by a proper site risk assessment And then from there, you can move on from it. So from my side, there's no guidelines simply because there's just too many variables in place. It's like if you drive your car, I can't tell you change exactly at 4,000 revs per minute. There are guidelines, there's principles, but you on site must make that decision by doing a proper risk assessment, and therefore you need to make sure that the guys on site can do a proper risk assessment. And we might have a workshop a little bit later on night work, but again, if your client says no, then Africa's tough. Client says no, you don't do night work because they've got specific statistical evidences in place that shows you cannot do night work for these and these and these reasons. So see night work the same as you would see inclement weather. Risk assess it, decide on it, and then get approval and move further. Sure. Right, here's a nice question. How can one protect themselves when working on rooftops with no existing anchor points? All right, so it's an easy question. Number one, do you need to go closer than 2 meters to the edge? If the answer is yes, then sorry, you don't work, because if you don't have anchor points, you can't go there. Secondly, we decide, is it worthwhile to get hand railings installed? So you get another company, they put temporary systems in place to install the handrail for you, and then that's a collective protective equipment exercise. And thirdly, if you have to go close to the edge, then you need to make sure that anchors are installed or a lifeline is installed to make sure then that you've got that proper work restraint system in place. So the answer in short, if you don't have anchors and you are in a full risk position, you cannot work. That's as simple as that. You have to mitigate your full risk position. However, if you're in the middle of the roof, it's a flat roof, and you have to put up a microwave antenna and you 10 meters from any edge, what is the actual fall risk? The fall risk might be fragile surfaces. Okay, so then you have to control it. So that's why a proper risk assessment is important, where you look at fragile surfaces, openings, is it a steel roof, how old is it? All those things need to be checked before you go there. And if you are exposed to a fall risk, you don't have an option. You need to have some sort of anchor point, being a lifeline, permanent, temporary, or then not at all. Then you use a cherry picker to do the work specifically from the cherry picker and do whatever you need to do. So you've got options, but at the end of the day, risk assess those options. Here's a nice question. It's from Hein, and he asks, okay, what do I do when I have to work alone if I've got a self-rescue system? All right, so I think this is going to be probably our second last question. So first of all, lone work, right? Okay, great. Now I plan ahead and I say, all right, I'm going to have a self-rescue system. So if I fall off here, I can just attach something and I can just lift myself up a little bit and come down, end of story. Right, that's all good and well. Now, we have to think of, what are the chances of me being injured? So I break my arm, my shoulder is out of joint. So then you start thinking, wait a minute, I don't have a buddy system, so nobody will check me. What's the likelihood of me being injured where I can't rescue myself? What's the likelihood of me being unconscious? Or now the things start to stack up against you. And I think we can all agree there is a likelihood that you may pass out. There's a probability that you will get injured, especially when you work on shock absorbers. What about your buddy system? What about people helping you to make sure that you are working safely? And if you take all those things into account, lone work, not optional. You cannot work alone, period. At least two. And if you are two guys, both need to be the rescuer. If Saki falls, Ppe rescues. If Ppe falls, Saki rescues. Okay, so it's as easy as that. Okay, I'm scrolling down. Okay, we've got another lighting question, and I think we've discussed that. Make sure that you do your risk assessment, proper lighting must be in place. Haha. Ooh. So I think I'm going to answer one more question, and then I'm going to ask Jandre to quickly scroll through. He's our producer, and he will tell me which one to use as our last one. Here's a good question on the elephant in the room, and it's not Bob. The question says, portable ladders are the biggest work at height risks. Why are we not doing proper training? So that, I think, is a very good question. So if you look at statistically, I saw the Canadian statistics, and they say that between 1 and 3 meters, the guys who died, it's about, I think they said about 40% of the fatalities was between 1 and 3 meters. Between 1 and 6 was another 20%. So technically, yeah, so what did I say? The statistic was 40 plus 20. So 60% of deaths occurred in Canada was between 1 and 6 meters. So surely that tells me something. That tells me, wait a minute, I need to make sure that the guys are using ladders correctly. And it's not as simple as, yeah, here's the ladder, go. There's a lot of variables in place. There's a lot of different risk assessment. Am I using the correct ladder for the task? Am I using the ladder as a work platform? So in my mind, if you use a ladder, yes, you need ladder training. How do I secure the ladder? What is acceptable? What's the different options of transporting the ladder? What are the different angles that I put the ladder against? How do I work from the ladder? So you need to have work ladder training. It's for me, it's a no-brainer. So as a fall protection plan developer, with these statistics behind your back that tells you 60% of the deaths occur between 1 meter and 6 meters. So what does that tell you? It tells you you must control the risk properly. And it starts with what? Training. And then we move on to equipment inspections, and if we need to rescue, but ladder rescues are typically easy, stretcher, there you go. All right, so the last one from my producer, what do you say, Jandre, is the question that you think is quite valuable?
I see there's a question from Service about cutaway rescues.
Ah, okay. Yes, I like that as well. Service, thank you for a good question. And so Service is asking, I understand that cutaway rescue should no longer be used. Was there a communication sent out on this regard? So it's an easier answer, but it's also a difficult answer. The easy part of it, yes, cutaways are no longer accepted. The second thing is, okay, who says that? So as an industry worldwide, people have done their risk assessments and they've seen cutaway rescues have a lot of risks that are inherently involved in it. The first risk is, in my mind, that if you cut away somebody, there's a big risk of that person shock loading the system. All right. And those of us who've done it, I think about 6-7 years ago, we trained it, and Every time I trained it, I was just, even my hands start sweating just thinking about it. For somebody who's not a trained rescuer, that doesn't work with it all the time, you cannot expect him to do a cutaway rescue, period. Shock loading is one. Setting up the system is number two. Number three, if you think about it, even with a safety knife, if you cut something, your first tendency is to go like this and grab whatever you think. Now you grab the rope and you cut the rope off. There's many incidences recorded where the rescuer actually tied himself to the patient and then he cut the patient's system off, and then down go the patient and the rescuer. So in terms of controlling the risk, in terms of having a rescue in place that's repeatable and safe, cutaway rescues do not tick the boxes. Yes, there is a place for it in terms of specialized rescue teams that practice it every day and they won't do silly stuff. But for a normal person doing work at height in a full risk scenario, there's no way I'm going to put that in my full protection plan. As a full protection planner, the risks are just too high. So service, there's no official legal requirement of not doing the cutaway rescue anymore. However, the legal requirement is the full protection planner must do a proper risk assessment. He must decide on the training, and he must decide, is this training efficient enough to make sure that 2 months down the line, 2 years down the line, Saki will still be using this system safely and correctly. So do I decide to take away the cutting knife from him and use a basic system? Of course, yes. If I include it, then I add all these extra risks, and now suddenly you are not creating a safe work environment for Saki. So that's my answer. Shivas, I hope that it answers your question. There's a lot of extra questions that I think. Oh, one more. We're running 5 minutes over time, but my producer says he's found a good one. So let's see.
Considering that the FFP developer is sometimes a consultant, drafting the FFP and never getting to a real site to ascertain the correct implementation, how will the FFP developer cover himself from a liability perspective if the supplier fails, or worst case, if the FFP developer does not even have knowledge of the various structures that can be encountered in the field, and as such write a plan based on best practice or personal experience?
Okay, sure. All right. So that question there's a lot of different aspects to that. I think the concern we've got in place is that if I get a full protection plan, how do I know that that full protection plan will be safe for the site? So if we go back to the appointment of the full protection plan developer, you have to appoint a competent person, and he must do 5 things. The first thing is risk assessment, medical, training, equipment control, and then rescues. So if you read it carefully, it says there that the full protection plan is dependent on a site-specific risk assessment. So there's the tricky thing that comes in. So as an employer, your question to yourself should be, right, if my staff starts working on site number B, have they done the correct risk assessment for the site, for the task? Have they identified the correct procedures to follow? Are those procedures in the full protection plan? Do they have the right equipment, the right training? Is there a rescue system in place? So the short answer is, without a proper risk assessment, the full protection plan cannot be site specific. So whoever does the full protection plan must take that into consideration. he must make sure that the process he develops is, I don't want to say independent, but is stands the reasonable man test that shows that the team has identified all the risks. My fall protection plan was written in such a way that whatever risk they achieved here, there is a SOP for that. And that SOP is then specifically applicable for the site. If they identify a risk here that's not in the fall protection plan, then the answer is simple. Stop work, go back to your plan, make sure then that you do a proper risk assessment and find the right SOP to follow to control that site risk properly and make sure that the persons doing the work have got sufficient knowledge and experience to identify the risk, use the correct equipment, and follow the correct procedure. If you can't answer that, then the fall protection plan means nothing. So the risk assessment is at the end of the line, and I think you saw that with all our questions that we've asked. Night work, rescues, now with is it applicable or not. So in my opinion, if a risk assessment is not adequate and you cannot identify the site risk that you need to identify and the control measure is not specifically stipulated in the fall protection plan, then that fall protection plan is no longer applicable to the site. You stop work, you go back to the fall protection plan developer, he pulls in a subject matter expert, you discuss the risk assessment, you discuss the control measures, and if you need to go to site because it's a special condition case, then the risk assessor or the subject matter expert goes to site, maybe for instance the rope access expert, goes to site, he does the first issue base and pre-task risk assessment with the guys to see if it's still applicable. If it is, then work carries on. So the fall protection plan and the risk assessment, they are together. And you can't have one without the other. And the legal requirements is pretty clear, regardless of the country that you are in. The risk assessment says the risk assessment must be done before work starts. Easy as that. And if the risk assessment is not applicable or is not supported by the fall protection plan, you need to go back to the drawing board and fix the plan. Right, I think that answers the question. There's a lot of questions that we've got in place, and I'm looking forward to our next session where we can have a nice discussion. I almost said lacquer. We can have a nice discussion on the questions that you have posted. My apologies for those who have not been answered correctly. Please make sure that your email is then addressed, your email address is available to us, and we'll probably get back to you with a specific answer to your question. If not, then stay tuned for the next workshop. I'm quite excited, and yeah, thanks for joining us. Please stay safe. And again, thanks for the Gravity staff who supported me through this process, even my wife. But yeah, thanks for everybody. I really appreciate it, and I hope you have a nice weekend. Thank you all. Bye.